Hello again. So in this video I'm going to be doing a calculation of the trip, 2 small legs for our trip to Kingston. If you didn't see the first video that kind of sets up the map and the leg and distances, you should go and see that. The link is in the comments. In this one I'm going to be doing the calculation using an ASA CX-3. You'll see it's very, very simple, and it's kind of super simple, really, just as simple as that. So let's do it. All right, so I have CX-3 here, a lot of buttons, but it really operates pretty easily. To start, press the orange button. What we want to do, we could do this using all the individual calculations using ground speed and all of that, but this actually has a plan, so we can use that. But first, I know it uses Fahrenheit. I haven't actually converted it to Celsius, so I want to convert my temperature to Fahrenheit. Sorry, to Celsius. So I want to do unit conversions, and I want to do temperature, and it shows Fahrenheit, so I'm going to put it in there. And my temperature is 12 degrees, and I want to convert it to Fahrenheit, so that's 54 Fahrenheit. Okay, good. So now I go back to plan. I'm going to connect. Basically, I'm going to be doing leg 1, which is real simple. And all I need to do is enter the parameters. It's going to do all the calculations for me. It's amazing, actually, this technology. So our distance, if you remember, was 75, because we're just doing the main leg here. The climb to altitude has all been done. True course was 200. True airspeed is 105. Wind direction is 330. Wind speed is 9. Variation is 14, and west is best, so it's plus 14. Got that. Good. Deviation, compass deviation, we don't know. We'll see when we get an airplane, or we'll see what it says in the airplane. Fuel rate is 6.3 gallons per hour, so 6.3. And then departure, let's say 10 o'clock. Or just to have a time. So the calculated values are: ground speed is 110, well, 0.56, we'll round that up to 111. Compass heading, don't know. Magnetic heading 218. So magnetic heading 218. True heading is 204, and our wind correction angle is 4, so yeah, exactly. Fuel 4.27 gallons, and our estimated time en route is 40 minutes and 42, so let's make that 41 minutes. So that works out to 51 minutes total here. Fuel is going to be, I'll round that up to a 3, so that's 5.5. Now, before going ahead farther here, I want to think about this. So my heading is 220, so that's southwest. My wind is coming behind me from a northwest-ish, so that means I'm going to have to turn crab towards the right, which will increase my heading. Okay, so 200 to 204 makes sense. And I have a tailwind, so my airspeed, so my ground speed is going to be higher. Exactly. Good. So that makes sense. I always want to double check these calculations. Good. So now we're going to go on to the other part here. So let's say we started off with 40 gallons. This airplane has 40 gallons. We're going to 1.1 would be our start taxi takeoff. That's from the POH. Climb and cruise 5.5. Circuits landing, I usually add 1.1, same thing, same number. So that comes up to 7.5. 0.7, nice symmetrical number. 10% contingency, let's make that 0.8. And 30 minutes reserve, so 6.3 divided by 2, that's 3.2, rounding up. So that's 7, carry 1, 11, 11.7. All right, so I'm going to do this now with, go back to calculators here, and I have 40 gallons minus 11.7, so I should have 28.3 fuel on board, and that would be, if I go back to flight, if I go to fuel, see where you actually get to use some stuff here. So I want to, well, I have duration. What I want is, my rate is 6.3. My volume is 28.3. And so that duration will give me 4.49 hours. Yes, so 4.49 hours. So my flight is going to be 51 minutes, which is essentially a 0.9 hours, and somewhere between 0.8 and 0.9, and I still have nearly 5 hours of fuel. So that's pretty good. So I'm going to stop there. This is sort of what I wanted to know. Now I could add to this side here the information, but I'll do this actually at the end of in a separate video, totally at the end. So you've seen how we use this in a very simple way to do a calculation of a leg. It's just follow the instructions really, and the rest of it is actually fairly simple. As you saw, it really didn't take me long to figure out how to calculate my residual fuel and its duration. I wasn't absolutely sure, but all I did is I put in the information I had, which was the volume, the quantity of fuel, and the rate, and it gave me the available duration. So as I was finalizing this video, I realized that I had forgotten to go back one step and calculate the calibrated airspeed. So how do we do this? Well, it's not very, very difficult, really. And what is the calibrated airspeed? It is actually adjusted for the altitude. So we need to know the pressure altitude and the temperature, or the density altitude. What we know is we actually have the information on that, so we can do this. So in fact, I started doing the calculation, so you'll see right away what it is here. So I put in 105 knots is our true airspeed. Outside air temperature, 12 degrees Celsius. Mach, we don't really care. And pressure altitude, 4420. And when I do that, all I need to do, it then gives me my calibrated airspeed, which is 97.37. So we'll just round that down to 97. Does that make sense? Again, always, whenever we're doing calculations, always decide or think a bit, is it making sense? And in this case it does, because we are flying at a calibrated airspeed of, at a pressure altitude of 4420 and a temperature which is warmer than standard. So therefore it makes sense that our indicated airspeed, what we'll see on our indicator, is going to be less than the true airspeed. So thank you for watching, and there will be a final video that really helps us to look at how do we set up the checkpoints and how do we use this in flight, this form in flight. Thank you for watching.